and welcome to this new video in this series of using ROS2 with game engines. In this case, we're going to use Godot, like in the previous video. If you haven't seen it, you can click there and have a look on how to set up things and how to get started. Also, you'll have a ROSject here down in the description where you can launch it very easily without any setup whatsoever. And that's it. So in this video, I'm going to show you how I implemented a custom class to be used in Godot so that we could use a subscriber from ROS2 to send commands from ROS2, in this case keyboard teleop, to Godot. And in Godot, we process that data and then we move a character around. Yeah. I won't go into details on how I did the game itself, the animations, how I exported it, how I did all the scripts there. But if you're interested, leave it in the comments below and I'll do a video just for you. Yeah, so let's get started. Here you have the game running. In this case, you see that it's a very simple Miximo character and with a very basic animations that you'll see in a moment. How this is structured and how is this working? I have a notebook here that you can follow to reproduce exactly what I'm doing here. Remember that when you start this ROSject, you have to execute some very basic commands to install things that won't be installed by default. Okay, good. So what have we done? Let me show you here. If I open this and my terminal and I press the keyboard teleop, you can see that I have control on the character using ROS2 topics. Yeah, so this teleop is publishing a ROS2 topic. There's a republisher around there that gets that keyboard teleop command and then publishes that in a topic where the Godot system is subscribed. And that's basically how it works. So you can turn, you can go forwards, backwards, and move forwards and backwards while turning. Yeah. And that's basically the result. So how did I do this? Let me show you the code. So we've done basically two things. One, create custom GDScripts of Godot to make this work. And on the other side, we've made a new class in the Godot ROS module, custom module for the Godot, so that we could use subscribers. Or at least we created a new subscriber. Yeah. So let's go into that first because I think it's very important to understand it. If you go to the source code here of Godot, you can see that in modules, as we explained in the previous video, we are using this Godot ROS that I leave in the video description also, where is the original source, who did it, and so on. Give it a like, by the way, for him, because he made a really good job. So here we have this structure. If you want to do a new class for a module, you have to first create two files. The first file is the .h file and the other one is the cpp file. As you can see here, I've made this cmd listener .h and also have this cmd listener. Let's go first to this cmd listener. There we go. So you can see here that we are importing the .h and then we are declaring essentially the methods that will be able to access of this new class, which is called cmd listener in Godot. So in Godot, we'll be able to access two methods. Get CMD, which basically gets the CMD data from the keyboard teleop indirectly, and then the spin sum, because we need to spin in order to update the callbacks for the subscribers. Otherwise it won't work, and no matter what you put in the topics, it won't update. Yeah. So let's have a look in the CMD listener. All the classes in Godot, the custom classes, work more or less the same way. They have the same structure. I won't go into detail there, but essentially I based it in the structure of the talker here, and I changed the class name. And here what we're doing is we are initializing a ROS node here with this name. Then we're initializing a quality of service, and then a subscription, subscriber. It's exactly the same as we would do it in a Gazebo plugin or something like that. It's very, very similar. The only thing is that we're not executing a main, for example, and we're initializing the node here, which it's a bit strange, but you'll see in a minute why we're doing this. Then we declare functions that we need, the destroyer. Then we have this spin sum, which essentially does spin sum of this node. Very simple, but we need to have access to this, otherwise it won't work. Then we have this topic callback, and this topic callback in this case is a string. I decided to do a string because it's very easy to process between Godot and ROS. Otherwise, if it was a CMD val, for example, a twist, it would be much more complicated because I would have to do a custom class and so on. So I just use strings. So every time that we get something in this topic, which is Godot CMD val, we process it and save it in process data. And then this method returns a string, the string of process data. And this is the data that we use to get the linear velocities and also the angular velocities. Yeah. And that's basically it. Once you have this, then you have to go to, in register types. And inside here, you have to register a new class for for Godot, which is this class DB register class CMD listener. And that's essentially it, because you don't have to modify here anything else, because we are in Scub, which is basically the CMake list version. You see that we're getting all the CPPs, so you can put as many as you want. Yeah, that's from the Godot part. The only thing that you have to do after you do this is you have to compile. I've set here, where are you? Here, the command to compile sconce with sconce, and it will only compile the modules that you've modified, so it's very efficient in that way. That's for the Godot part, the module. Okay. Once we have this, then we have to define how to use it in Godot, in GDScript, associated with all the elements in the game. So let's have a look at that. So as you can see here, we have the game running here. So let me stop it for a moment. And here you have the Godot IDE. And here we have the main, and I won't go into details of all the elements here. This is more Godot related, but I've created this scene, which is the dummy robot version 2. And inside it, we have this one, which is the animations. We won't go into detail there. Then the collision shape, again, related to Godot, how you move elements in the scene. Then the camera, that it's only used so that we can see what's going on. And here is the one. this, I made a spatial element, and inside it I added this script, which is essentially what we need. So what we're doing here is initializing this command listener new, which has to be the same name that we set here, command listener. Yeah. So command listener, and we are creating a new one. This will initialize the subscriber that we declared here. All this, basically when we do cmd listener new, what we're doing is execute all this. And once we have it, we initialize some variables, which essentially are the x and the linear x and the angular z that we're using. And inside here, we are initializing a timer in Godot that will be executed every 0.1 seconds. And this is our loop, our main. And this way we control the frequency of how many times we call this. Every time we call it, we have here the spin sum, you see, which will execute all the callbacks of our node, which in our case is 1, to see if there's been some change there. And inside here, we do ROS cmd listener get command, which will return this string with the data of the command file. Then we check if it's empty. Basically, this is the initialization value that we see here. You see? There we go. And now we split it. We will, in the way we are formatting this, we'll see it in a moment how we do this, is we separate the linear and the angular values with this symbol. With the symbol, we use the symbol to do the split, so we can get, again, both values separated. And we check that it's 2, and then we access the values, we convert the string to float, and that's basically it. And we save this into these variables. And you say, okay, then how does the character move? The character moves because we have this the script here, which is inside the main element here. And what we're doing is accessing this ROS systems element, which gives us access to those variables. Then you see here that we implemented this function, this method, which calls this get command velocity linear x, which is here, and also this one, which returns the values. And we use this to get the values indirectly that way. Then we use this method to decide which way to go, what to do, which animation to play. If we go forwards, backwards, we turn left, right, this kind of stuff. And here we can use it with the keyboard, but also we can use it with the linear velocity, which is the purpose of all this exercise. But you can also use the keyboard if you want at the same time. And here we just decide what to do. And this one is the main physics process, that it's the loop that it's being executed every delta time. So we get the commands, we decide what we have to do, and then based on that we set this direction.z and this around here, there we go, this rotation.y, so that we rotate the character and we move the character. And which direction, forwards or backwards. Once we have this, because we are assigning an animation based on if we're going, for example, let's say I have to go forwards, so I set the animation to walking. But what if I go backwards? Then what I do is execute the walking animation, but backwards. And that's why we're setting this. I want to turn left. Then if I also want to go forwards, then I'll go forward walking, but turning also, using this rotation. If not, if I'm only turning, then I execute the animation of turning. And here we play it. This is what executes the animation. And once this is done, then we do the calculations to set the speed and acceleration and so on, so that the rigid body, the physics body, moves around the scene. Yeah. And we set it like this using this move slide, which moves the element around. I won't go into detail how this works. And that's it. So the last piece of the puzzle is how do I move it? Then for that we have to go to our ROS2 workspace, which there you go. ROS2 workspace, source, and inside here we have this Godot ROS packages that I created, and inside here we have a command vel publisher which does this bridge. It subscribes to the command vel and publishes into this Godot command vel. And what it does is it's receiving the data. It's receiving the data, and then what I'm doing is stringifying. Let's say I'm processing the data in a way that I'm getting the linear velocity here dot x and the angular dot z, and I add this, and that's it, and I publish this. With all this done, you should have something, well, similar to this. So you have this playing around, then you go here, and you have to execute two things. You have to execute the Godot control start command vel republisher, which is this launch that I defined here. There you go, very simple, just launching a node. And finally, we execute the cmdvel, which the keyboard delay, sorry. And now if I go here and I go here, then I can move around forwards, backwards, and turning. I didn't get the animations that well synchronized, but we'll get there, And that's it. So this has many applications because you can use this for sending data, other kinds of data. So now you know how to, maybe we can in the next video talk about the talker, so publish data, and we will try maybe to publish, I don't know, laser point cloud data, who knows. Leave it in the comments below if you want that I do something particular. And that's it. Thanks a lot for staying until the end. Please leave a big, huge like and subscribe if you haven't still. And leave it in the comments if you like the video, if you like this new format, if you like this topic, leave it in the comments. And that's it. Until then, peace.